Welcome to another session, another video brought to you by Odavig Structure Hub. This is a place where you learn, build, and innovate. Today, I want to solve example number 3, and this is under stability of a retaining wall. So the question is from Kenya National Examination Council, and that is Module 2. And the question is on the board, and it reads, figure below shows a retaining wall which support a cohesionless soil having a density of 1800 kilogram per meter cubic and a shearing resistance of 28 degree. The density of the wall material is 2400 kilogram per meter cubic. Examine the stability condition of the retaining wall with regard to number 1, tension in the joints, number 2, ground bearing pressure, number 3, factor of safety against overturning, and then number 4, factor of safety against sliding, assuming angle of wall friction is equal to 0.9 phi. So the question carries 20 marks, and this is the retaining wall, and this is the retained soil. So this is the dimension of the retaining wall: 1.2, 4.4, 1.2, then 1.2, 2.4, 1.2. Note, all dimensions are in meters. So let's see how you can solve such a question. So the first thing to do, as usual, is to draw the pressure diagram. After drawing the pressure diagram, then we will start calculating the pressure exerted on this retaining wall. So let's draw the pressure diagram as a result of the retained soil, and we'll draw it here. So that is the pressure diagram, and the intensity of this pressure at the bottom is given by Ka times unit weight of soil times H, whereby Ka is the Rankins coefficient of active pressure. And then we assume this pressure is acting at this point, and this is the active pressure. So the distance from the base to where the force is acting is given by H over 3 from the base. Like that. So again, we have the passive pressure, and since this is the base of the retaining wall, and the base is part of the foundation, so we'll assume our ground level is at this point, and this is the soil, and this is the ground level. So we will have also an active pressure, a passive pressure, like that. So this passive pressure, we assume is acting at that point. So this is PP. The intensity of this passive pressure at the bottom is given by Kp unit weight of soil times H. So this is the different H from here to here, like that. So after doing so, now we can start tackling the question. So the question requires us to examine the stability condition of the wall with regard to Roman 1 tension in the joints. So we begin by calculating the forces acting on this retaining wall. So we will begin by PA, which is the active pressure. So it's given by W H square over 2 into bracket 1 minus sine phi over 1 plus sine phi. So this in bracket is what we call the Rankins coefficient of active pressure, and is this here is this Ka. So in simple terms, the active pressure will be the area of this pressure diagram, which is a half base times height. As you can see, this is the base and this is the height. So if you take this formula, which is a half base times height, we will arrive on this formula WH square over 2 into bracket 1 minus sine phi over 1 plus sine phi. So let's continue. So allow me to clean here so that we may have space for more calculation. So W is the unit weight of the soil, and in our question we have been given the density of the soil as 1800 kilogram per meter cubic. So the density of soil is given by 18 kilogram per meter cubic. So we'll first convert this to unit weight. So you will take 18 times 9.81 and then you divide by 1,000. So we are converting to Newton per meter cubic. So we multiply by gravitational acceleration, which is 9.81, then we divide by 1,000, whereby 1,000 Newton is equal to 1 kilonewton. So if you carry out the operation, you will get 17.66 kilonewton per meter cubic. Now, in our formula, PA is equal to 17.66 times H. H is 1.2 plus 4.4 plus 1.2, which is 6.8 square over 2 into bracket 1 minus sine 28 over 1 plus sine 28. So PA is given by, so PA is equal to, if you carry out the operation, you will get PA as 147.41 kilonewton, and then is acting at a distance of 6.8 over 3, which is h over 3. So we have already calculated our PA. This is our horizontal force, which is PA. Now, this horizontal force, we can obtain overturning moment. So overturning moment is equal to PA times h over 3, whereby PA is 147. So moment overturning is equal to 147.41 times 6.8 over 3. So if you carry out the operation, you will get our overturning moment as 334.13 kilonewton meter. So that is our overturning moment. So this is our overturning moment. We now proceed to the vertical forces. Which will help us to calculate the resisting moment. So again, allow me to erase here. So we have the vertical forces. So for us to calculate the vertical forces, we will divide. As you can see, this is a combination of several shapes. So we can divide so that we can have the base like that, and then the rectangle and the triangle. So we'll call this stem 1, stem 2, and this one the base, like that. So the vertical forces will be the forces as a result of the self weight of this retaining wall, and also if the retaining wall is extending beyond the backfill or beyond the retained soil. For example, if you can have a hill at this side, it means the backfill will have an effect on the vertical forces. So we will consider the force as a result of the backfill if there is a hill extending on the backfill on the retaining soil. But for our case, as you can see, there is no extension on the retained soil. So no need to consider the vertical force as a result of the backfill. So we'll only calculate the forces as a result of the retaining wall. So I have divided this retaining wall into 3 portions. As you can see, we have number 1 is the rectangle, number 2 is a triangle, and then number 3 is the base. So we will first calculate the area of this number 1, then we multiply by the unit weight of the concrete, By doing so, we'll have calculated the force of number 1. And then we proceed to number 2. So for number 2, it will be also the area times the unit weight of concrete. Also number 3, the area times the unit weight of concrete. And before we can start calculating the forces, let's first calculate the unit weight of concrete. So we have been told to use 2400 kilogram per meter cubic. So this one is equivalent to 24 times gravitational acceleration, which is 9.81 over 1,000. So you will get 23.54 kilonewton per meter cubic. So that is the unit weight of concrete. Now you can begin calculating the forces for this retaining wall. So we begin by number 1. Let's say force in stem 1, like that. So it will be area, which is 1.2 times this distance from here to here. So that is 4.4 plus 1.2. So that is 5.6 times 23.54, which is equal to 154.5 kilonewton. We proceed to force in stem 2, like that. So this one will be the area of this triangle times the unit weight of concrete. So the area of this triangle is a half base times height. So the base is 2.4. So it's a half times 2.4 times h. H is this distance from here to here, which is 4.4 times 4.4. Then times the unit weight of concrete, which is 23.54. So you will get 123.29 kilonewton. And then you proceed to the base. So the base, it will be length times width. So the length is 1.2 plus 2.4 plus 1.2. So that is 4.8. So we'll have 1.2 times 4.8 times 23.54, which is equal to 135.59 kilonewton. So after doing so, we will get the summation of all the vertical forces. So summation of vertical forces is equal to this one plus this plus this. So you get 413.38 kilonewton. So that is our vertical forces. After so, we can now calculate our moment of resistance or resistance moment. So allow me to clean here. so that you may have space for more calculation. So moment due to all vertical forces. So this one is given by force times lever arm or a perpendicular distance. So we begin with force as a result of stem 1. So our force in stem 1 was or is 154.5 times. Now, let me show what a lever arm means. So for this returning wall, the overturning will occur at this point. At this point. A. So for you to get the lever arm or the perpendicular distance, you will consider this distance from point A to the center of shape number 1. So that is our lever arm. So as you can see, it is 1.2 plus 2.4 plus 1.2 over 2. So 1.2 plus 2.4 plus 1.2 over 2. So if you carry out the operation, you will get 648.9. 648 equals to 648.9 kilonewton meter. We proceed to stem number 2. Our force in stem number 2 was or is 123.29 times the lever arm. So lever arm is this distance from point A to the center of this triangle. So it will be 1.2, so into bracket 1.2 plus 2 over 3 times 2.4, like that. So if you carry out the operation, you will get 345.21 kilonewton meter. We proceed to the base. So our force in the base was or is 135.59 times the lever arm. The lever arm is the center of this distance from here to here. So you will add 1.2 plus 2.4 plus 1.2. So the total distance is 4.8 times 4.8 over 2. And you will get your answer as 325.42. 3, 25.42 kilonewton meter. And then the resisting moment is equal to, you'll take this, add to this, and then you add to this. So you'll get 19.53 kilonewton meter. So that is our resisting moment, 1319.53 kilonewton meter. Now, having calculated our resisting moment and our overturning moment, we now go back to the question. So the question says, examine the stability condition of the wall with regard to Roman 1 tension in the joints. So I will begin by tension in the joint. So allow me also to erase here. So tension in the joint. So we know that for tension in the joint, if E is less or equal to B over 6, then no tension will occur. Like that. And you know that E is equal to B over 2 minus X. And if we can draw the base of the retaining wall like this, so that is our base, and then that is our center. So this is our distance E, and this is distance X. And here is B over 2. And this is where the resultant cut the base. So to get distance X, we use this formula: moment of resistance minus overturning moment over summation of vertical forces. So this one is equal to our moment of resistance. Our moment of resistance is 19.53 minus 3, 34.13 over the total vertical force, which is 4, 13.38. So X is equal to 2.4 meters, and E is equal to B over 2. So if you can add 1.2 plus 2.4 plus 4 plus 1.2, we'll get 4.8 over 2 minus 2.4, which is equal to 0. So it means E is equal to 0. So let's see if we'll have tension in the joint or not. So our E, which is 0, should be less or equal to 4.8 over 6. It proves, therefore, 0 is less than 0.8. No tension in the joints. We proceed to question number 2. So number 2 is ground bearing pressure. So ground bearing pressure So we know that P maximum is given by summation of vertical forces over B into bracket 1 plus 6 E over B. Our summation of vertical forces is equal to 413.38 all over B, which is 4.8. So B is this distance from here to here, into bracket 1 plus 6 times E, which is 0, over 4.8. Therefore, P maximum is equal to 86.12 kilonewton per meter square. So P minimum is equal to summation of vertical forces over B into bracket 1 minus 6E over B, which is equal to 413.38 over 4.8, 1 minus 6 times 0 over 4.8. So our P minimum remains the same as P maximum, which is 86.12 kilonewton per meter square. So that is our ground bearing pressure. We now proceed to Roman number 3, which is factor of safety against overturning. Factor of safety against overturning. So that is Roman number 3. So factor of safety against overturning is given by resisting moment over overturning. Moment, and it should be greater than or equal to 1.5. So our resisting moment, we already have it, which is 13, 19, 0.53 divided by 334.13. So the answer is 3.9, which is greater than 1.5. Therefore, no overturning will occur. Like that. We proceed to the last one, which is sliding. So we proceed to sliding. So you know that factor of safety against sliding is given by resisting force over sliding force. And resisting force is given by mu multiplies the summation of vertical forces plus passive pressure. So mu, you have not been given mu in our question. We have not been given mu in our question. So what we have in our question is in our question, what we have is the angle of wall friction, which is given by (0.9 phi). So mu is calculated using this formula, tan delta, which is equal to tan into bracket 0.9 times 28, which is our phi. So if you carry out the operation, you will get mu as 0.5. So our mu is 0.5. So resisting force, which is given by this formula, will be 0.5 times summation of vertical forces 413.38 plus the passive pressure is the pressure of this pressure diagram. So that one will be W H square over 2 1 plus sine phi over 1 minus sine phi. Remember, this is the coefficient of Rankine's active pressure, which is Kp, and Ka is the Rankine's coefficient of active pressure, which is the opposite of this one. So it will be 1 minus sine phi over 1 plus sine phi. But for the passive, is 1 plus sine phi over 1 minus sine phi. Put this operation, which is 0.5 times 413.38, you'll get to 6.69. And then our W is the unit weight of the soil, of which in the question we were given the density of the soil, which is 1800. So we will multiply by 9.81 which is the gravitation acceleration. So by doing so, we will have our unit weight in Newton per meter cubic, and then you divide by 1,000 to convert it from Newton per meter cubic to kilonewton per meter cubic. And then our H is 1.2. This distance from here to here is 1.2 square over 2. And then into bracket 1 plus sine phi, which is 28 over 1 minus sine phi, which is 28. So if you carry out the operation, you will get your final answer as 241.9 kilonewton. And then we proceed to factor of safety against sliding, which is resisting force over sliding force. So the resisting force is this one, 2. So factor of safety, against sliding is given by resisting force, which is 241.9 over the sliding force, which is PA, and our PA here is 147.41, and it should be greater than or equal to 1.55. So if you carry out the operation, you will get 1, which equals to 1.64, and this one is greater than 1.55. Therefore, no sliding will occur, like that. So we are done with this question, and we can also draw the bearing pressure on the ground as a result of the minimum pressure and the maximum pressure. So we calculated earlier, and our maximum pressure was 82, same as the minimum pressure. So if we can draw here, so our maximum pressure will occur at A and minimum pressure at B. So this is 82 and this is 82. So that is the pressure the ground will bear. So that is the end of that question. And for those who have not subscribed to this channel, please subscribe and hit the notification bell so that you may be the first person to be notified when I upload a video. In my next video, I will be designing retaining walls. So in designing, we will be able to determine the distance or the base, the thickness of the base, and also the distance of the toy, the distance of the heel, and so on. So stay tuned for more updates. Thank you for your time, and we meet again in my next session.